Hello students, so welcome to this turbo machines, and we are in hydraulic pumps. Then centrifugal pump we are dealing with, and the previous video, so this is what we have seen, the heads of the centrifugal pumps, and we have seen what is suction head, what is delivery head, what is total head, and what is manometric head. So in the systematic diagram, schematic diagram, what we have seen is like the different positions and different heads, how it is placed, and how it is called. So this way we have seen. So we have seen a suction head, and we have seen delivery head, and we have seen total head. And let us see what is manometric head. So we'll understand what exactly it is, because suction and delivery is very simple. From ground level to eye of the impeller suction, eye of the impeller to overhead tank is delivery head, and the combination will be called as a static head. So coming to this manometric head, we'll move on to this manometric head and we'll try to understand what exactly it is. Manometric head or effective head. So it is defined as the head against which a centrifugal pump has to work. So that means that the centrifugal will work from the ground level to the top level, even the surface of the ground level. Below that there is some sort of friction. So some sort of not friction, it is some sort of head will be available in that. So including that head, so it will be called as effective head or manometric head. So it includes all the losses like frictional losses, obviously, leakage losses. So all these things will be there, and other losses are neglected. So manometric head is equal to Euler's head, that is the head imparted to the liquid by the impeller. The manometric head is given with the following equations. Now, as per the equations, the manometric head is equal to head imparted to water by the impeller minus head loss in the pump. So manometric head is equal to U2 VW2 by G minus HL. HL indicates the head loss. So if head loss is neglected, because it is a smaller value, since it is neglected, then HM is equal to U2 VW2 by G. Now coming to this manometric head is also given as a total head at the pump outlet delivery minus total head at pump inlet, that is suction. So in that way, if you write a manometric head HM is equal to PD by PG rho G plus VD square by 2G plus ZD, that is delivery head, minus PS by PG plus VS square by 2G plus ZS, that is for suction head. So the P by rho G is equal to pressure head, then v square by 2G is velocity head, and Z is equal to height of the datum line. So now manometric head is the combination of summation of static head, delivery head, and friction, that is at the static, and friction at the delivery, and then Vd square by 2G. So Vd is nothing but velocity of water in delivery pipe. So H of S and H of D is frictional head loss in suction and delivery pipe respectively. So this is all about this manometric head. So now let us see what are the efficiencies. Now we will see the different efficiencies of centrifugal pump. The various efficiencies involved in the analysis of centrifugal pumps are: one is manometric efficiency or hydraulic efficiency. So it is defined as the head, manometric head to the head imparted by the impeller to the water. Mathematically it is written as manometric head is equal to manometric head efficiency is equal to manometric head divided by head imparted by impeller to water. So any efficiency, it is taken as output by input. So here manometric efficiency is equal to output as manometric head and input as head imparted by impeller of water. So let us write. So HM is the manometric head divided by head imparted to impeller to water, U2 VW2 by G. So that is equal to G HM divided by U2 VU2. So second one is mechanical efficiency. It is the ratio of power available at the impeller to the power at the pump shaft. So mathematically it is written as, so mechanical efficiency is talking about power. So power at the impeller divided by power at the pump shaft. So power at the impeller is nothing but rho Q U2 VW2 divided by power at the pump shaft is shaft power SP. So that is the mechanical efficiency. So coming to this volumetric efficiency as ratio of actual discharge to theoretical discharge, that is flow rate flowing through the suction pipe. So mathematically it is given by the equation actual discharge by theoretical discharge, that is QD by QS. So next one is overall efficiency. It is defined as the power output of the pump to the power input to the pump. So mathematically, so overall efficiency is equal to water power divided by shaft power. So water power can be written as rho Q G HM divided by shaft power SP. So alternatively it can be written as overall efficiency is equal to water power divided by shaft power. So water power divided by impeller power into impeller power by shaft power. So that can be written in that way. So water by impeller is nothing but manometric efficiency, and impeller by shaft is equal to mechanical efficiency. So finally, overall efficiency is the um, multiplication of mechanical efficiency and manometric efficiency. So these are the efficiencies. Now let us see what are the different losses. One is hydraulic losses, mechanical losses, leakage losses. Next one is minimum speed for starting a centrifugal pump. When a centrifugal pump is started, it will start delivering liquid only if the pressure rise in the impeller is more than or equal to the manometric head. So here u2 square minus u1 square by 2g is greater than or equal to manometric head. For minimum speed, we must have u2 square by minus u1 square by 2g. This is the manometric head. So manometric efficiency is equal to manometric head divided by vw2 u2 by g. So finally g hm divided by vw2 u2. So manometric head is equal to, so we can cross multiply like this, and where the u1 is equal to pi d1 n by 60, u2 is equal to pi d2 n by 60. If you substitute all these things in the main equation, so you will get the manometric efficiency into vw2 by g into pi d2 n by 60. So if you simplify this, finally you will get a minimum speed that is equal to 120 into manometric efficiency into Vw2 into d2 by pi into d2 square minus d1 square. So this is all about the minimum speed for starting a centrifugal pump. Now let us see what is all about this cavitation. So cavitation is nothing but in a simple way, if you say that the centrifugal pump, the pressure is lowest at the inlet, and what you call the water bubbles will be formed in the suction region. So this water bubbles, what happens when water is moving, flowing through the pipe, so the bubbles will be carried and flowingly in through the along with the flowing liquid, and it goes to the higher level, and before the exit of the impeller, these water bubbles will collapse by colliding with each other. So due to this collapsing of these bubbles, the metallic surface and the high pressure is because of the high pressure, the metallic surface will have a pitting action on the surface and produces noise and vibration. So that phenomena is nothing but cavitation, and we can see this cavitation in the pictures. I will show you later. So this is the cavitation. This figure you can see the cavitation because through the impellers, because these bubbles will collide with each other, and while collapsing, so it will give some noise and vibration, and there will be a pitting action takes place. So that is nothing but the cavitation. Thomas cavitation factor is used to indicate the onset of cavitation. So Hs is equal to Hs plus Hfs plus Vs square by 2g. So atmospheric head is equal to HATM is equal to atmospheric pressure head. Now coming to this, what are the factors which are responsible for cavitation is, one is the high impeller speed, small diameter of suction pipe and inlet of impeller, too high specific speed, then required, so NPSH is greater than available NPSH, and then high temperature. So if you look at this, so cavitation decreases with the decrease in the value of NPCH, and then high temperature of flowing fluid. Right, these are the factors which are responsible. Now we will see the harmful effects of cavitation are the pitting and erosion of surface, sudden drop in head, efficiency, noise, and vibration. So these are the effects of the cavitation.